What's up, guys? We will be modding this servo motor for it to spin continuously, so it's not a servo but a DC motor. We will start by disassembling. Use a PH1 screwdriver, and then just screw all the screws out. We will be needing a few things for this. We have the DINS connector up top, a small limit switch from 3D printer, and some spare wires. Oh, that was not all the way out. And then of course a soldering iron and all of that good stuff. See, it does like to bind sometimes. Let's just do it the old-fashioned way. Take these out. Jesus Christ. There we go. Alright. So, broke the gasket. Well, it doesn't matter. Alright. So we have the DC motor and the driver circuit. There are a few parts to this. Your motor might look a bit different, but we don't really need any of this. So we will be desoldering the pads from here. And like that. And then we have the small sensor at the bottom. So we need to desolder these as well. And it might be a bit tricky actually. You might be able to just desolder them directly from down here. That was one. Maybe two. Not all the way. Three. There we go. And then you can just keep this or throw it out. Doesn't matter. You can also, if you are very skilled, push the metal chassis out, but just be very careful you don't push it all the way out, because then you come into the gearbox and it will be very hard to assemble this again after you disassemble it. So try keep these two parts together. Okay, nice. Now the motor is done and ready. Now we will take our limit switch, and we can see on this, maybe, yes, you can see a common and normally open, an O and an NC, normally closed. We want this to be I actually have to remember, it must be normally open, and then when you press down it has to close. So we will solder one of our GST connectors to this part directly. So for me, I found out it works best to just add some solder to the sensor itself, or the switch. So these two pads out here, there and there. Whoop. And just solder these up. It doesn't really matter. If you want, you can actually add some thing. Let's just do that to do it properly. So cut some shrink tube down. Add this to the wire. It is really not necessary, but it does keep the wires nice and tidy and prevent any shorts. So solder this, and the colors doesn't matter because it will just be in series of the motor, and then the black and white wire does. Black and red, of course, doesn't make any difference. Okay. Now you can slide there we go, the parts over, and if you have a hot torch or hot blowing thing, you can do it, or just use a lighter. There we go. Now that is done. Okay, for the motor part, this is a bit more complicated. We need about 32 centimeters of standard doubled wire, or just two single cords, doesn't matter, and then the female side of the JST connector. So for this wire we will cut out about 5 millimeters of the end, split it out a bit, twist the wires, just prevent them from getting bent and everything else. And then we will have to add some larger shrink tube, whatever you call it. Oh, you can actually add that afterwards. the most important thing here is that we need to add a string tube to the connector, because the Dean's connector has a positive and a minus, and of course this is the male side, and on the female or the battery side it's a female plug, because we don't want this to be shorted on the battery itself, of course. You are working with LiPo batteries, so please take your time and check everything is correctly placed. Then connect your Deans into some kind of vise. You can also hold it, but it's easier this way. And you can see it says plus and minus. So black goes to minus and plus is red. Where's the soldering iron? There it is. Okay. And again, pre-tint the wires so it's easy and faster. There we go. Then also add some solder to the Dean's connector. This is quite a large surface, so they need to be heated up quite a lot compared to other smaller components. There we go. Alright, and now, as I said before, add the string tube. Probably most important step. If you don't do this, you can cause the battery to cause fire. The vertical one is plus, and then horizontal one is minus. So we will add the black one to the minus, and plus to plus, of course. I'll make sure they are good soldered. Then slide the string tube over and heat it up. And you can see immediately it will start to shrink. It does make pretty good sense. String tube will shrink. And then the other one we cut from earlier, we can just slide it on the other end. This is just from keeping the wires nice and tidy and preventing them from getting loose. And then just add string it. Alright, now that end is done, we can put this aside. Alright, for the other end, do the same thing again. About 5mm. Cut it. That was probably a bit more, but doesn't matter. And twist it so it doesn't splice. You don't have to do it, it's just a nice way to keep it tidy. Alright, on the motor end, let's just tin this first, because then they don't fuck up later. So, tin it. And the other one. There we go. And then you can, if you want to, just cut up the axis. Alright. For the motor side, you can see most likely there's a red dot. It indicates that it's the plus side. And the most confusing thing is that we don't connect plus to plus here, because the way the motor spins, if we have the driving wheel placed on top and it rotates, if we connect plus to plus, it will rotate the wrong way around inside the EAS. So we will have to solder this plus here to the minus side. Or you can also do it the other way around, so minus connects to plus, it doesn't really matter. Let's just put this aside. Then we take the let's just connect these two, because then you can see what I mean. Then we take our switch wires and we want to place them in series between the battery and the motor. So the current run from here inside the motor, actually let's just say the other way around. It will run from the battery into the switch where it is normally closed. Then when we press it, it opens up, current flows through into the motor, and does the motor thing, and then out again. So this will have to be soldered to this and this. To solder these two together, I just need to find the string tube. It is there. It doesn't matter what color it is. This is yellow. Add a good amount of string tube. There we go. And now we just have to look. It doesn't really matter, but let's just connect the plus here. There we go. So we add this together. Then we take the two wires. Let's see if we can do it free-handed. Nice. them together, and you can see it very clearly when it's soldered correctly. And then it makes pretty good sense where the last one go. It of course goes to the battery. No, of course not the battery, the motor. There we go. And then we slide over the string tube again. Place it of course in the middle as much as you can, and then just heat it up so it shrinks. Okay. Now for keeping the wires tightly, we will place them inside the motor. So we have two wires going out. We have the sensor or the connector or the switch, whatever we call it, and then we have the power. Okay, and then we have to find the top. It is there, and the gasket gets broke, but again, doesn't really matter. It's not inside any water. But then we add the cutout to this side. Slide it down and make sure all the wires are nicely packed in there. Hold everything together and add the screws. And like everything else from my builds, don't tighten it in a clockwise motion, but do it the opposite around. Let's just get that off, for fuck's sake. There we go. So tighten this one just a tiny bit, then do the opposite side. And why do we do this? Yes, because if we do it the clockwise around, we can tighten this part down too much, and then some kind of warp can occur over the surface. It doesn't matter on a small part, but if it's a very functional part, like a gearbox in a 3D printer, this has to go in a opposite motion and don't in a clockwise, so we tighten it wrongly. It's just a good practice. Okay, now the motor is done, and you can test it with your battery. And it should not, connected, there we go. And it should not turn on until we press the button. Awesome, it works. So, this is now ready to be installed into the EAS. You can watch the other video on how to assemble it. There's also a video on how to use thread inserts. If you are not comfortable doing all of this using DINS connector and LiPo batteries, it is kind of dangerous. If you short one of these bad boys, it will cause a massive fire that you cannot put out. Ask me how I know. I almost burned down this house before. Then I will have a kit available on my website. You can buy it, and then you get all of this in pre-assembled, so you just have to assemble this together, and then you're good to go. Yeah, makes pretty good sense. This is for the version 2 and non-advanced version. For the advanced version, there will be another connecting method. We will use a H-bridge, so connected for controlling the motor. And therefore this switch won't go in parallel, but will go, not go in series, but kind of go in parallel. Microcontroller will read the switch and then use a H-switch and some transistors to turn on and off the motor. So it can be converted again. Of course, it's quite simple, but for this it only works for the basic version. So if you just wanted the slave or very basic version, so it when you push down on the nozzle, it turns on. There we go. It turns on, off. Very simple, always works, but you can overload the magazines this way, and it can damage them. So it works. It's quick and simple. It's very cheap, and it's so reliable because nothing really can break in this. So happy printing, guys, and happy shooting, of course.